what I want you to do is I want you to kind of follow along, and I want you to create a graph while I'm creating your graph. And then at the end of the video, you should have an example of a graph that would score maximum points on that. So if you would, I'm going to set this outside of the screen of the video because I want to see everything right here. But I just want to point out to the camera that we're taking our data from here. And we're going to plot this data on a graph that I'm going to make on the board. The first thing when you do a graph is please do it on graph paper. I don't have graph paper up here, but I spent like 20 minutes like measuring a grid up here so that I could do this. All right? The second thing you need to consider is you've got a y-axis and an x-axis. Now we just say x and y because you're familiar with x and y from math class. Because in math class, you're not really talking about specific problems so much. It's just like, oh, let's just make a graph and we'll make it x and y, and the equation of the line is y equals mx plus b. Those are just two variables that are conventionally used when you're talking about a graph. But mind you, in science, it's not x, y. It is independent variable and dependent variable. And when you're making a density measurement, what you are actually manipulating, what you manipulate is the independent variable. The dependent variable depends on whatever the independent variable is. Whatever the independent variable is what you did, what you manipulated. And you got to choose how much fluid to put into the graduated cylinder. So you measure different amounts of volume, and then you measured the mass. So your volume is the independent variable, and some of you may have been taught in middle school this thing called dry mix. Dry. The dependent variable is on the y-axis, and the variable that you manipulate is the independent variable on the x-axis. The independent variable, the x-axis, is going to be the volume. And that the dependent variable is going to be the mass. It's very important that you're not, this is a scatter plot of data. That's what we're going to use most in science. I get the impression that most of you in middle school did bar graphs. And that's not what we're doing here. Because I think I joked one day, I says, oh, you guys are used to doing bar graphs like Old MacDonald's farm. Old MacDonald had so many cows and he had so many chicks. Bar graphs are for graphing categories of data. Here we're looking at a scattering of data. So when you do a scatter plot, you have to look at your range of data and then find a convenient increment to mark off your ticks on each axis. So if I want to do my x-axis, I'm going to look at the volume and I'm going to say the biggest number I've got here it has to go up to at least 159. Let's round that up to some number, 160 milliliters. So I'm going to make my x-axis go from 0 to 160 milliliters. And then I count the number. So you want this to be on the center of your page, and you won't want it to be crowded up in a corner. You want it to cover most of the width of your graph paper. So I'm going to speed ahead. You guys might be struggling right now counting how many blocks that you have between 0 and 160 now. This is where you actually kind of have to give some thought to the layout of your graph. I've already given some thought to the layout of my graph, and I know that this is going to be, I think, tens. Let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60. Yes. So each of these are, each of my tick marks is going to be 10. And likewise, the range of my y data is just about as wide. My y data goes up above 150 or 147 up to about 150. So I'm going to have to, you know what? It's really, really convenient if you have both axes in the same increment, but that doesn't always work out. But today, for our purposes, each tick mark on the y-axis is also going to be worth 10. This is what's called a linear axis. So when I'm grading your page, I want to see that each tick mark has the same value. Again, we want labels. I say volume here. These numbers don't mean anything to me unless I know what the units are. So the units of volume are milliliters, and the units of mass are grams. Notice that I put the abbreviation for the unit in parentheses. So I want you to label your x-axis volume in milliliters and your mass in grams. So I use the parentheses. All right? Next thing you do is I want you to go ahead and plot your points. You've already set up your both x and y axis, or your volume and your mass axis. And for those of you who are taking the notes, you might be struggling to measure these really quick. I'm doing this because I've already kind of thought out what I wanted my graph to look like, and so I already have these plot points. You have to measure these accurately, and I want you to put an X. Yeah, Sarah. What do we plot? We are plotting mass versus volume. So my first point is 147 by 159. So I go 147 is my mass, and 159 is my volume. There's my plot point. Then I've got 110 and 102. So here is 110, and here is 102. There's my next plot point. Then I've got 74.55 and 81. Here's 74.55 and 81. And then I've got 26 and 22. So I've got 26 and 22. I'm going to be looking for X marks. Sometimes it's kind of hard to see dots on your page. Next, line of best fit. Here's another freshman mistake. Students will connect the dots. That's not what a scatter plot is. If I say do a line of best fit, then that means there's no perfect fit. You're just trying to do the best job you can. So that means, and I like to use a clear ruler because I can see what's underneath the ruler, because when you draw a line of best fit, you want as many dots above the line as you do below the line. I don't think that's a good line because look, that one looks like it's really far away. I've got 2 above and I've got 2 below. Let me try that again. I don't know if that's any better. You can kind of eyeball the distances here. Once you have your line of best fit, don't connect the dots. Remember, it's an average, so you're trying to come as close to as many data points as possible. And then don't extend beyond your data, because you really didn't take any data down here, so you really can't draw that line. Likewise, don't extend this off. Don't extrapolate.